Okay, Assalamu alaikum, dear students. So let's start with today's lecture. Today, our topic of discussion is metals for casting. Before this, you have covered multiple steps involved in the casting processes, the different types of casting processes, the what are the measures that we look for, and now we are in the position of explaining what kind of metals can be used for casting. So when we talk about metals, we are actually referring to alloys. And alloys are basically formed with metals combining with some other elements. They could be metals or non-metals. So alloys have much better commercial properties. That is why we always used alloys in the casting processes. So, when talking about metals, we have two types. One is the ferrous metal, and another is the ferrous, non-ferrous metals. Or in terms of alloys, we can call it ferrous alloys and then non-ferrous alloys. Okay, so let me write it here. Is the ferrous alloys. So in this part of the lecture, I'm focusing on ferrous alloys. Ferrous alloys includes two types. One is the cast iron. And cast iron, you know that it is most widely casted alloy. It is the most widely casting alloy. It almost count for the 75% of the total casting that is done overall the world. Okay, so it counts for 75% the total casting metals in the world. Okay, so it includes different types of cast irons, which is the gray cast iron. It also includes the white cast iron, the malleable iron, the alloy cast iron, and one another is the nodular iron. Okay, so these are different types of the cast iron. Okay, so the temperature, the melting temperature is somewhere of these all type. The melting temperature of all these types of cast irons are somewhere 1400 degrees centigrade. Okay, that's quite high, and it's okay. When we compare to steel, it's comparable and it's okay. So let's come towards the second type of ferrous alloy, which is the steel. And when talking about steel, let me highlight it. Okay, so steel has much better mechanical properties when compared to cast iron, and the reason is that that is why we use it as a engineering material. It is much attractive material, and it has much better strength, much better toughness, the weldability, and other good properties. Okay, so first let me write that it is much attractive material, much attractive engineering material, and it includes the good technical properties. We will be focusing on that, but it has the good thing is that with the casting steel we can cast much complex shapes or much complex castings. Okay, but it has some difficulty in the foundry because we are dealing with much higher temperatures, and there are issues of oxidization. So, for example, it has difficulties in foundry while casting. Steel, the solidification temperature or solidification begins at around 1540 degrees centigrade. Okay. So almost the pouring temperature for this case will be equal to 1650 degrees centigrade. So this is quite high temperature. 1650 degrees centigrade is quite high temperature, and the issue is at this temperature the steel uh, has the issue of oxidization. Okay, so that is why the with such high temperature steel oxidizes. Okay, so we need to take some measures to isolate the melting metal from air. Okay, because at the pouring point or the melting point, that it has oxidization issues, and oxidization is basically reducing your product quality. Okay, so you need to avoid this phenomena, and for this you need to do some isolation mechanism to isolate the molten metal from the air. So that is all about steel. And if we talk about some benefits or some good points about steel, so it has much better strength, good strength, has good strength. Likely the tensile forces could range to 410 megapascals. Similarly, it has better toughness. It's the energy absorbed during the elastic region. So it has better toughness when compared to other castings alloys, uh, when compared to other casting alloys. Okay. Similarly, the weldability, it has much better weldability. Okay, it means that it uh, can be welded easily when compared to other metals. Okay, so better weldability. Okay, and one another point is the isotropic behavior of steel when we cast it. Like it means that the strength of the steel is constant in all direction. Okay, so we call it is isotropic, while other methods of dealing with steel is like forging or rolling the uh, mm, properties are not directional. Okay, so the properties are actually directional, sorry, because the properties will not remain same in all parts of the uh, steel uh, product. Okay, so it has isotropic because the is casting is uh, or we can call it the strength properties remain same in all direction. reactions in casting. Okay, so that was all about the ferrous alloys, includes the casting iron and the casting steel. And next lecture we will be covering the non-ferrous alloys.